Hello and welcome to this video. In this video we will solve 22nd set of problems, that is problem number 211 to 220. So as always I will say that you should pause the video and when I'm stating the problem, and if you cannot solve the problem yourself, only then look at the solution. So these are easy problems relatively compared to what we have done. So question 211 says that for what values of m is missing, 1 plus m x square minus 2 into 1 plus 3m into x plus 1 plus 8m is equal to 0 has equal roots. So if you look at the roots of binomial quadratic equation, those are minus b plus minus square root of b square minus 4ac by 2a. So roots will be equal only if square root of b square minus 4ac is 0. So b in this case is 2 into 1 plus 3m and a is 1 plus m, c is 1 plus 8m. So that's what it is written. Discriminant has to be 0. So we put d is equal to 0. We square the b, which becomes 4 into 1 plus 3m whole square and minus 4ac, which is equal to 0. We take 4 common and we have this another equation, 1 plus 9m square plus 6m minus 1 minus 9m minus 8m square, which becomes m square minus 3m is equal to 0, which gives us two values of m, 0 and 3, for which the equation will have equal roots. So very straightforward formula based questions. Question 212 says that if a plus b plus c is equal to 0 and a, b, c are rational, prove that the roots of the equation b plus c minus a x square plus c plus a minus b into x plus a plus b minus c is equal to 0 are rational. So again we look at the discriminant. The discriminant is c plus a minus b whole square minus 4 into b plus c minus a into a plus b minus c. If you evaluate this, you will get 4 into b square minus 4ac. We are given that a plus b plus c is equal to 0. So b is equal to minus a plus c. We plug the value of this b in here and we get the discriminant as, after simplification, 4 into a minus c whole square, which is a perfect square, and thus roots will be rational because a, b, c are rational. Question 213 says that show that if the roots of the equation a square plus b square into x square plus 2 into ac plus bd into x plus c square plus d square is equal to 0 are real, they will be equal. Okay. So roots will be real only if d is greater than or equal to 0. So we calculate the discriminant d. We have 4 into ac plus bd whole square minus 4 into a square plus b square into c square plus d square, which becomes equal to minus 4 into ad minus bc whole square. Okay. So roots will be real only if discriminant is greater than or equal to 0. That is, minus 4 into ad minus bc whole square has to be greater than 0. So since it's a negative sign, we arrive at ad minus bc whole square less than or equal to 0. But since it's a square, it cannot be less than 0. So the only possible value is that ad minus bc whole square is equal to 0, which implies that discriminant d is 0 because roots are real. They have to be real. So once discriminant d becomes 0, the roots become equal because they are real. So that's what we conclude. Now we move on to question 214. If the roots of the equation a into b minus c x square, b into c minus a into x plus c into a minus b is equal to 0 be equal, prove that a, b, c are in HP. So again, roots will be equal only if discriminant is 0. So we let capital A is equal to a into b minus c, capital B is equal to b into c minus a, and c is equal to c capital C, this should be capital C, 214. Okay. Capital C is equal to C into A minus B. Now if you look at this, A plus B plus C is equal to 0. Since roots are equal, that is D is equal to 0, B square minus 4AC is equal to 0. You follow from this, okay? There small a plus B plus C was, which one was this one? Sorry. A plus B plus C is equal to 0 was which one? 212, okay. Leave it. So, what we have is A plus B plus C is equal to 0 from these three, okay? And roots are equal. It is given in the question that roots are equal. So that means discriminant D is 0. Yes, B square minus 4AC is equal to 0. And we substitute from here B is equal to minus A plus C, which gives us A minus C whole square is equal to 0. That is A is equal to C. So now we substitute the value of A is equal to A into B minus C, and C is equal to C into capital C is equal to C into A minus B, which gives us 2AC is equal to AB plus CB. That is B is equal to 2AC by A plus C, and this is the harmonic mean of two numbers. So ABC are in HP. Now we look at question number 215. It says that if A plus B plus C is equal to 0 and A, B, C are real, prove that the equation B is missing. Prove that the equation B minus X whole square minus 4 into A minus X into C minus X is equal to 0 has real roots, and roots will not be equal unless A is equal to B is equal to C. So our given equation is B minus X whole square minus 4 into A minus X into C minus X equal to 0. We expand it and we get minus 3X square plus 2 into 2A plus 2C minus B into X plus B square minus 4AC is equal to 0. Now we compute the discriminant of this. We arrive at, it's a simple manipulation, 8 into A minus B whole square plus B minus C whole square plus C minus A whole square. Now ABC are real, so D has to be greater than 0 or equal to 0, okay? But since so the question was 215, okay, the has real roots, and roots will not be equal unless A is equal to B is equal to C. So roots are real, that means D is greater than or equal to 0. The only possibility of D being 0 is that A is equal to B is equal to C, because it's a sum of 3 squares, so all three have to be 0 simultaneously. So D becomes 0 if A is equal to B is equal to C. So roots are real unless A is equal to B is equal to C. Now we come to question 216. Show that if PQRS are real numbers and PR is equal to 2 into Q plus S, then at least one of the equations x square plus px plus q is equal to 0 or x square plus rx plus s is equal to 0 has real roots. So the respective discriminants are p square minus 4q and r square minus 4s. We add them, we get p square plus r square minus 4 into q plus s. Now if you look at this, we are given pr is equal to 2 into q plus s. So it becomes p square plus r square minus 2pr, that is p minus r whole square greater than or equal to 0. Once we have that, at least one discriminant is greater than 0. Okay, either this is greater than 0 or this is greater than 0, because otherwise the sum of discriminant cannot be greater than or equal to 0. We have added two discriminants, right? And we find that the sum is greater than or equal to 0. So at least one of the discriminants have to be greater than 0. And that equation will have real roots. Both can have real roots as well. So question 217 says that if the equation x square minus 2px plus q is equal to 0 has two equal roots, then the equation 1 plus y into x square minus 2 into p plus y into x plus q plus y is equal to 0 will have its roots real and distinct only when y is negative and p is not unity. So we look at the discriminant of first equation, which has equal roots, is 4p square minus 4q is equal to 0, that is p square is equal to q. Now we write the discriminant of the second equation as simplify, we get 4 into p square plus 2y plus y square minus q minus qy minus y square. Now we substitute the value of q as p square. Okay, so this becomes p square and this becomes py, a p square y. So once you do that, the equation will become minus 4 into y into p minus 1 whole square. There is something wrong here in this calculation. Y square is not here in the equation. Okay, so you can simplify this. Okay, whatever it comes, it will be square. All right, roots of the equation will be real and distinct only if d greater than equal to 0, but p minus 1 is greater than equal to 0 if p is not equal to 1. Thus y has to be negative as well. Maybe the calculation is correct. I cannot mentally perform this calculation. So if you put p square here, p square will get cancelled. I don't know. So okay, let's do it. All right, plus y square minus y square cancelled. P square and q is p square cancelled. So this is 2y and this is minus q square y and this is y. So p square y, q square y and 2y. So we can take y common and then we will have p square and 1 and 2p. So yeah, p minus 1 whole square. The calculation is correct. Question 218 says that if the equation x square plus 2bx plus c is equal to 0 has real roots, a, b, c being real numbers, and if m and n are real numbers such that m square greater than n square greater than 0, then prove that the equation ax square plus 2mbx plus nc is equal to 0 has real roots. There is an extra quote here. All right. So we look at the roots of the equation x square plus 2bx plus c is equal to 0 and they are real, not equal. Okay, real roots. So this should be real. 4b square minus 4ac, which is the discriminant, will be greater than equal to 0. Now discriminant of the equation x square plus 2mbx plus nc is 4m square b square minus 4a and c. Since okay, it is given that m square greater than n square. There is something wrong with this question. This should be n. Okay, we will see. I'll correct it in the PDF. So when you download the PDF, I'll show it then. This will be corrected. So m square greater than n greater than equal to 0 implies that b square greater than ac. So m square is definitely cancelled out with n. Okay, so the question is not correct. This implies that b square greater than equal to ac, which implies that 4m square b square minus 4a and c greater than 0. Thus roots of the second equation are real. Question 219 says that if the okay, there is an extra case. So you see a lot of typing mistakes are there in the PDF. Question 214, 218 and 219 have issues, and then there is extra quote in this. If the equations ax plus by is equal to 1 and cx square plus dy square is equal to 1 have only one solution, prove that a square by c plus b square by d is equal to 1 and x is equal to a by c, y is equal to b by d. So this is again a straightforward question. So we substitute, we find out y from this, y becomes 1 minus ax by b, and we substitute it in the second equation. So second equation becomes cx square plus d into 1 minus ax by b whole square is equal to b square cx square plus d into 1 minus x whole square by b square is equal to 1. We simplify this and we arrive at b square c plus d square into x square minus 2a dx plus d minus b square is equal to 0. Since the two equations have one solution, this equation will also have one solution, which means roots will be equal. So d is equal to 0. So for this equation, the discriminant will be 0. So we just compute the discriminant and simplify, and we arrive at b square c plus, this should be a square c, a square d, this should be a square d. So it seems I typed a to the power d instead of 2d. Okay, so once we have that, we divide both sides by cd we get b square by d plus a square by c is equal to 1. Once we have that, we substitute the values and over here, and we get, or rather that in this equation, and we get x is equal to a by c, and we substitute this over here, we get y is equal to b by d. So now we come to the last problem of this set. We let if r be the ratio of roots of the equation x square plus bx plus c is equal to 0, so that r plus 1 whole square by r is equal to b square by 8c. So, okay, 220. All right. So r is the ratio of roots of this equation. We have to show this. All right. So we let the roots to be alpha and r plus r alpha because the ratio is r. So if you divide, you get r. Now sum of roots would be alpha plus r alpha is equal to minus b by a. So alpha is minus b by a into r plus 1, and product of roots will be r alpha square. So we substitute the value of alpha from here. We get rb square by a square into 1 plus r square is equal to c by a. Once we have that, we can say that b square by ac is equal to r plus 1 whole square by r. Pretty simple problem. So compared to previous problems which we have solved, these problems are very simple and you don't need a lot of intuition, just simple calculations will do. So with this, we come to the end of 22nd set of problems on quadratic equations and theory, polynomials and theory of equations. So these last 10 questions were strictly based on quadratic equation, and following questions will be also based on quadratic equations. We will rarely deal polynomials of higher degree. There may be few questions, but mostly now it will be quadratic equations. So I hope that you are finding this series of videos on polynomials and theory of equations interesting and useful and informative as well, because mathematics is all about solving problems. Mathematics is not about theory. Theory helps you in solving problems, but the real work is in solving problems. Okay, theories are in general very straightforward to understand. Once you get it, it may take some time depending on the type of theory, but once you get the theory, the real skill is solving problems, because problems can be of various types. As you will grow later into your studies during graduation and masters, you'll see that the problems can get very nasty and you need a lot of intuition, and that is where math becomes hard. Till class 12th, math is not hard. It can be hard if the questions are of very high level, like Olympiad level or above, then those questions are hard. But in graduation, in general, problems are very hard. So with this, I will conclude the video. Do not forget to subscribe the channel. If you are not subscribed, press the bell icon and do all those things like make use of comment box, share, and whatever good things you can do with this. And the most important part is that you share the video and share the channel with your friends. And because the reason is I want to help as many people as I can. So as a student, it is up to you to help your friends. I do not charge anything for my videos. Some people make courses. There are coaching classes which give you videos. I don't do all that. I don't run a coaching. I give everything for free. So make sure that you help your dear friends and share the video. If you have questions, let me know in the comments and I'll try to do my best to answer those questions. By the way, before I conclude, I'll show that where you can download the PDF. So you can go to astrologer.org, and here we have the second item in the list, a variable in algebra 2025 1128. So this means it is updated on 28th December 2025. So you click the link and you get this PDF in your browser. You can use the save button here. Okay, and you can save the PDF on your mobile or laptop or desktop to read. The typing mistakes will be corrected, and when it is corrected, this date will change. So always make sure that the PDF which you have is downloaded at a date. If this link has a later date, then you need to download again for corrections. So all the chapters are done in this book you have up to 9 chapters, and then solutions are all done. And there is a 10 chapter miscellaneous problems. So a lot of problems are given. For example, if you look at miscellaneous, you have more than 700, almost close to 800 questions are there. So a lot of problems are there for practice. You can download. There is no hard copy. You can't buy it Amazon. You can't buy anywhere. It's just not there. I will probably never publish it. So I wish you luck in your studies. Enjoy.